Okay, this is going to be kind of the last chapter for chemistry for the school year. I'm actually going to combine parts of chapter 14 and 15 together, talking about properties of acids and bases. That's today's objective. Then we're going to look at definitions of acids and bases. There's going to be 3 definitions, and so I'll kind of we'll cover some today. Well, actually, I think I'll start tomorrow. But just talking about how they get a little bit more broader as we go along, and then what happens when you mix acids and bases together. And then I'm going to have this kind of like makeshift section that's not listed here that talks about how do you measure the pH of solutions, you know, if you're given some unknowns, and then finish off with titrations. So properties of acids and bases. So acids, kind of 5 big properties. First off, when it is an aqueous solution, they tend to have a sour taste. Now, I'm not recommending that you go around tasting every single acid you come in contact to determine that it has a sour taste. Just take my word for it. But a lot of acids that we can consume do have a sour taste. Acids tend to change color in acid-base indicators, and so I'll talk about some of those on the next slide. Third property, some acids react with metals and release hydrogen gas. Now, we saw a lot of this during our unit where we did 12 different chemical reactions for the 5 types. Mix in hydrochloric acid with zinc, putting that stopper on top of it and trying to ignite that hydrogen gas. So, yeah. If you also remember the flame test lab, right, where we had to use hydrochloric acid to clean our little wand things, we noticed that it actually ate away on some of those metals, right? Okay, 4th property, acids react with bases to produce salts and water. So we call this a neutralization reaction, where if the concentrations are just right, you will produce salt and water theoretically. So you could take 2 harmful substances, mix them together, and produce water and salt. And no, Jacob, we are not going to do that. And then finally, acids conduct an electric current. They are very good conductors. There's ions that float in an aqueous solution. You can take a lemon and make it turn it into a battery, if you will, by making it turn on a light bulb or something. I've seen so many experiments of that. But moving on to acid-base indicators. Now, there's a couple different indicators. And the first one I want to talk about is litmus paper. Now, there are 2 types, or I should say maybe 3 types of litmus paper. Blue litmus paper, red litmus paper, and universal pH litmus paper. So blue litmus paper, if you soak it in an acidic solution, it will turn red. If you take blue litmus paper and you soak it in a basic solution, it remains blue. So the bottom line here is blue tends to be basic. Red tends to be acidic. So you can do the same thing with red litmus paper. If you take red litmus paper and you soak it in a basic solution, it will turn blue. If you take red litmus paper and you soak it in an acidic solution, it will turn red. Now, universal pH paper makes this pretty little rainbow. It gives you degrees of how acidic or basic or alkaline it is. And so red tends to be acidic and blue tends to be basic. And then in this neutral part, it tends to be green. So we see this pH scale of 0 to 14. We haven't talked about the pH scale yet, but low pH numbers result in acidic substances. High pH numbers result in basic or alkaline substances. Now, there are other indicators that you can use as well. So it doesn't have to be just these 3 types of paper. You can actually use like other liquid chemicals like methyl orange or bromophenol blue. Turns blue in the presence of a base. Phenolphthalein turns pink. For an acid, it remains colorless. So, Okay, naming acids. Naming acids is actually pretty easy if the acid is a binary acid. Binary acid means it just has 2 elements in it. So some examples: HF, HCl, hydrogen and chlorine, HBr, hydrogen and bromine, HI, hydrogen and iodine. So the rules for naming it is the prefix is hydro, because you have to have a hydrogen as one of them, and the other one is just a very highly electronegative element. So we start off with hydro. Then the second part is the root name. So the root name is basically the second element, and then you end it with ic, and then obviously acid. So here are the rules. Here are some common root names. Chlorine is chlor, S is sulfur, Br is brom, F is fluor, and then I is ide. So if I have HBr following the rules, I start off with hydro, and then it's Br, brom, and then the suffix ic, hydrobromic acid. H2S, I start off with hydro, S is sulfur, and then ic, so hydrosulfuric acid. HCl, start off with hydrochloric acid. Now you can go backwards. How do you get the chemical name or the chemical compound? So we have hydroiodic acid. I don't know how the hell you say that. But anyways, hydro is H, and then ide is iodine, so it's just HI. Hydrofluoric acid, HF. Okay. So we have binary acids. We also have oxyacids. Acid that is a compound of hydrogen and oxygen, and then a third element, usually a nonmetal. So HNO3, hydrogen, oxygen, and a nonmetal. H2CO3, hydrogen, oxygen, and a nonmetal. H2SO4, hydrogen, oxygen, and a nonmetal. So binary acids, two elements, one is hydrogen, the other one's nonmetal. Oxyacids, acids containing oxygen within there as well as a hydrogen and a nonmetal. So no oxygen, has oxygen. Moving on. Now acids are pretty useful in industry. So I'm going to talk about, I think, 5 types here. Sulfuric acid is used in petroleum refinery, metallurgy, fertilizers. It's also a very effective dehydrating agent, which means it removes water. So here's some other uses. Nitric acid, usually made in the production of fertilizers and explosives, but it can be used to make rubber, plastic dyes, as well as some pharmaceuticals, this polyamide here. Phosphoric acid, fertilizers and animal feed. It's also used as a food additive. In fact, I'm drinking a can of Coke right now, and if I look at the nutrition label with the ingredients, it says phosphoric acid. So, yeah, dilute forms of flavoring agent, cleaning agent for dairy equipment, detergents, ceramics. Then we have our hydrochloric acid. Our stomach produces it, but it's mostly used in pickling, iron, and steel. But pickling means removing impurities, and it's also a general cleaning agent. And here's some other uses of hydrochloric acid. Acetic acid, also known as, or it's actually found in vinegar, is used to make chemicals in the manufacture of plastics, aids in production of food, supplements, and can be used as a fungicide. Okay, that does it for properties of acids. Moving on to properties of bases. So acids taste sour, bases taste bitter. And again, I do not encourage you to go sip on ammonia and taste the bitterness, right? Bases change color in acid-base indicators. So I'll just recap that on the next slide. We have dilute aqueous solutions of bases feel slippery. A lot of times bases are cleaning agents. Bases react with acids to produce salts and water in a neutralization reaction, and then bases can also conduct electric currents. So just to recap, bases tend to be blue with litmus paper. Okay, that does it for today. I just talked about properties of acids and bases. Tomorrow I'm going to talk about the first definition of acids and bases.